Hello everyone, this is Tushar again with a new topic. Hope you are doing fine. So today we will be discussing how solar energy is extracted from sun. We all know that solar is expanding to the occupants in the today's power sector. So we should discuss it, and it is more important than our currently non-renewable sources. So let us start. So solar modules which are used to extract the power from sunlight are made up of small solar cell arrays. These arrays are made up of silicon wafers. As we all know, sand is the biggest source of silicon which we can use in our industry. So we extract silicon and process it to make a compound of SiHCl3. So this is the compound basically which is used to make the silicon wafer. So let us see the atomic structure and the combined structure of SiHCl3. How does it look? Basically, this will be having interconnection, which also has some free electrons in it, and atoms are connected to each other with some free electrons, but these electrons are not as much capable to give us the amount which we can categorize as current, as they will be very minimal. So this is like the structure here, and these are the electron bonding which I have shown here. So here comes the picture of doping. Doping is basically adding the impurity in the current structure so that we can get some amount increased in the number of free electrons. As we all know that only we are not changing the structure or atomic structure of any metal here. So we are only giving the doping so that we can get some electrons flow, which we can categorize as electrons. As we all know that current is nothing but flow of electrons. Okay, so we bring two semiconductor layers which are N-type and P-type. We all know that N-type semiconductors are the semiconductor which have the majority free charge carriers of electrons, and P-type semiconductors are the semiconductors which have majority charge carriers of positive, that are holes. Holes are not like they have the positive positive charge. Only holes are formed from where the electrons move to the other place. So the void they create in any metal, that will be termed as a hole, which we consider as positive, as it has less negative charge. So we consider it as more positive, because we are considering only positive and negative. So wherever the negative charge will be reduced, we will consider it as positive charge. So that will be termed as holes, and electrons are of negative charge. That will be terms for the N-type semiconductor. So I will show you how the N-type and P-type semiconductors are sandwiched to make a PV wafer, or I can say silicon wafer. So as we have studied in our early school classes that two semiconductor are sandwiched and they will form a depletion layer. I think you might be remembering the word depletion layer. So here we have the N type and here we have the P type. So N type will have more number of free electrons in it, and P type will have, as I demonstrated, will have more number of positive signs, positive charge, or I can say more number of holes. But these N-type semiconductors does not have as much amount of free electrons as much we need, so that we can consider it that our current is flowing. So we add some impurities in it and name it as doping. But this is very important. You cannot add anything to any semiconductor. So we add negative type semiconductor with phosphorus and p-type semiconductor with boron. Okay, these two types of impurities are added, and these will help in increasing the electrons and positive charge carrier in both the side, which will help us to increase the depletion layer and get little bit more voltage and current. Voltage is basically the amount of it which will force the current. Basically, voltage is nothing but it is forcing the current to flow in any material. That is voltage. Resistance is if I say practicality theorem of any resistance, I am saying it is holding the resistance to move from itself. Okay, that is the resistive quality of any metal, any material, or I can say metal. So the light from the sun will come as a photon to this point of the N-type layer, which is kept above the wafer. Obviously, there are the protective glass films on the both of the side to make this strengthen the wafers, because initially, if we talk about only the wafer, it is so thin that it can be broken by putting your finger on it. So that is why it is named as wafer. Okay, so when the sunlight comes here, before that, when you place it, there will be a depletion layer here, which does not allow any type of charge carrier to change its position from the p-type to n-type. So these positive charge carriers try to pass, as it has positive and it has negative, and both will attract each other. So they will start depositing here from both the sides, and they will keep on increasing the depletion layer width. So when the photon strikes this wafer, so when these N-type and P-type layer will come in contact, the N-type layer, which is near to the depletion layer, will get more positive signs. You will be amazed that mostly the N-type has more free electrons, but due to the science behind these depletion layer, all the positive signs come near to the depletion region, and all the negative signs come in this side of depletion layer in p type. Okay, so here it is too much like packing that there is no free electrons and holes in this depletion region, and it keep on increasing the size. Okay, so very interesting happens when the photon comes to the picture and it reaches the depletion layer. When it comes to the depletion layer, it creates too much free electrons. This is depletion layer. This is depletion layer. I am talking just to make it little bit more clear that it creates positive and negative signs free. So signs, I mean charges free to move in this, so that they can create a movement and which creates voltage and movement of current. Okay, so this kind of depletion and these charges keep on flowing into the both the layers, keep on moving. So the electrons flow in N type to P type. Electrons are flowing from N type to P type because P type has more holes and N type has more electrons. So it tried to get the position, electrons try to get the position in P type and settle down, and in P type there are more holes which try to get settled down in the N type. So the electrons move from N type to P type, and we all know that in the direction where electrons flow, in the opposite direction the current will flow. So the current flows from P type to N type wafer. So means current will come in this direction and electrons will come in this direction. Electrons will come in this direction. Okay, so when the battery is connected here, we get the energy stored in the battery, which is DC, because there is no frequency related thing in this system. So we get DC as an output, which we can use directly for a DC system, but for AC system we have to use inverter and connect it to the inverter and then utilize the AC output. So I think I have tried to explain the mechanism of solar energy in very brief and point to point way. So I think you have understood. Thanks for being so patient, listener. Have a nice day.